In this video, we're going to be looking at exponential growth and decay, specifically on the theme of your doubling time and your half time of a quantity. So the thing that I want to start with is the explanation of the formulas, because often I get a question from students asking, which formula do I have to use in this equation, and so on and so on. So the simplest way that I can explain to you is by using an example of your compound interest. So firstly, let's just assume we are asked to find a certain balance after a period of years. So first thing that we have to write the standard form of our equation, exponential equation. So I'm just using b in terms of balances, so we know this is the standard one. But in an instance where they tell you that you are going to be depositing a certain amount with an interest that is compounded, let's just say for instance at a rate of 5%, and they want you to determine the balance after a certain years, like 6 years, and they also tell you that it is compounded monthly, then you're going to have a formula that looks like this. You will have your balance, you have your initial, you have your 1, your rate over n, then you have your n multiplied by your t. See, so this is the initial balance that you're going to, or the deposit that you're going to deposit initially. They will give you your rate, your n. Remember, they can tell you that this one, it can be monthly, it can be annually, it can be weekly, it can be daily. For monthly you will use a 12, for annually you will use a 1. We have 52 weeks. Daily you use 365. Then what else? Quarterly. Then your quarterly, you know you're going to use your form. So basically your n, this is the number of times you are going to be making those payments within that 5 years. They are going to give you the number of years in that situation. Then you have to find the balance. So now we get to the last formula, where you have your b is equals to your b0, and then you have your e to the exponent rt. So you see the order of how we go. This is the normal one that they would give you, where they want something simple like your balance. They just give you the initial, then your a. Here we know this one, it's your exponential growth or decay. Then your t, this one is your time. So if they just want something that's simple, they would give you your initial balance, then your exponential decay. Then we know our a, it's given as 1 plus your r. They will give you also the rate, and they will give you the time. Then but for this one, this is the one where they will tell you that it is compounded monthly, annually, or any of these two. So when we get to this one, this is the one that we use each and every time they tell us that something is continuous. Okay, so now what do I mean by something is continuous? You see in equation 2 that we did have n, but in this one, what happens? We don't necessarily have a specific n. So our n is trying to approach positive infinity, but it will never reach positive infinity. It means here in this instance, we are going to be making as many deposits as possible within that 5 years. So let's just suppose in this one we were finding the balance within 5 years. So it means now if we have something like this, or your ends are going to be more than 12, it means we will have to use this one, which is continuous, because you don't have a specific number of times that you're going to be doing those deposits, you see. So also just notice by the word continuous. So here I was just trying to explain the background of how these formulas work. So now we're going to go to this one and say, okay, but here we're not working with balances, we're working with what? We are working with quantities. Yeah, you're going to say you have your Q is equals to your QO, you have your E to the exponent RT. You see? Then you check that, okay, what did they give you? They gave you your 5%, and now what you have to work, you basically have to work out your T. Your T is the one that is unknown. So how do we work this one? So the thing that you have to keep in mind also is, at what time T does the quantity equal twice the starting? Which one is the starting? This is the starting quantity. So one thing also to add, it does not matter what amount you start with, it always takes the same time to double. So meaning I can come and say I have my twice quantity, or the initial one, then here you have that initial, then you have your E, then your R. It's going to be, I'm trying to divide this by 100, the 15% divided by 100, what do you get? Oh, 0.15. So you get your 0.15 T. You see? So these ones, what happens? These ones, your Q0 are going to cancel. You're going to have 2 is equals to your E to the exponent 0.15 multiplied by that T. Then now we know if we want to bring this one down, your 0.15 T, we're going to introduce a ln. So if you want to erase your base E, you introduce your ln. Then if you have your ln and you want to erase it, you introduce your base E. So that's basically how it works. It works vice versa. It means here we're going to introduce a ln of 2, then we're going to have what this side? We're going to have our ln of we have E to the exponent 0.152. Then we can have ln of 2, this will be equals to, so if we have something that looks like this, the rule says that we can actually take this one and bring it down. So we're going to have our 0.15 T multiplied by ln of E, and that's basically how we erase that E, because what happens, your ln of E, this one, it's basically, it gives you 1. So how are you going to write this? You have your ln of 2 would be equals to 0.15 T multiplied by 1. So we've basically gotten rid of that ln of E. See? So now what's left? What's left is for us to divide by 0.15 divided by 0.15. So we'll say our T, it's approximately it's approximately 4.6 So it's 4.6 they're giving us. Okay, they're looking for years, so it's approximately 4.6 years. See, so in the second one we're going to look for the one where they're talking about the half-life, because this one, it was the doubling life. So you remember the important thing about this formula that you have to note. So yeah, so now we have example 2, which says determine the half-life of a quantity decreasing at a rate of 15% per hour. But in this instance, you see, they've just made it easy that we have to use this formula, because you see in the other question we had noted that if it's something that's continuous, we're definitely going to be using the formula that has base E, but in this they just made it easy for us, so it means we just have to do the calculation. And one thing that I have to highlight is that, okay, you have to pay attention to what they in the other question. They were talking about let me just verify. Oh yeah, the rate was growing at 15%, but in this one they're saying the rate is decreasing at the rate of 15%. You see, that one was positive. In this instance, this one is going to be negative. So that's one highlight I wanted to make. It means this K, your factor of decay or growth, is going to be, we're given the formula, so we can continue and say we have Q0, we have E, the exponent KT. Then what did they say? Then from this we have to find the half-life of a quantity. Then we can come and say we have half of Q0, we have Q0, we have E to the exponent, I think it's minus 0, yeah, minus 0.15. We have minus 0.15 T. So we're still going to be following the same procedure we did on the last video. So on the last example, so that one is going to cancel that one. We're going to have half, then we have E to the exponent minus 0.15 T. Then I said, if we're working with E and we're trying to remove it, we introduce a ln. We have a ln of 1/2. This is your ln of E to the exponent minus 0.15 T. Then we will have a ln of 1/2. Then we know the rule says we can basically take this one and step it down. We have minus 0.15 T multiplied by ln of E. This is the same as having ln of, let me just write the 0.5 here. We have 0.5, this is the same, 1/2 is 0.5. We have minus 0.15 T, then ln of T, this is 1. Then now what happens is that you just have to divide by minus 0.15. You divide by minus 0.15, this cancels, then this is minus 0.15. Therefore your T would be equals to how much? Then this one rated, okay, it's going to be 4.6 hours. See, so that's basically how you do this type of example. So yeah, I do hope you found this video useful.